All right. Welcome once again. We want to start with another year, as in solving another past question, chemistry jam past question for the year 2016 to be precise. So I remain your tutor, your teacher, and Johnny Oluwafemi Excel. So let's look at 2016 jam question. The first question that we have here says that in an electrochemical cell, polymerization is it caused by oxygen, hydrogen, tetraoxosulfates 4, acid, or chlorine? Don't forget our usual method. Tell me what you feel the right answer is in the comment section while I review to you what the answer is. Then you can now compare. And then I will also explain the reason why I'm choosing that particular answer, or the reason I've chosen that particular answer to the question displayed on the screen. So, these are the options. So the comment section, just feel free to put whatever you feel is the right answer there. But the answer to this is actually B. In an electrochemical cell, polymerization is caused by hydrogen. And the reason is because polymerization occurs when hydrogen gas accumulates on the electrode, especially the cathode, during electrolysis, forming a barrier that impedes the flow of electrons. Okay, so that is what happens. So polymerization occurs when hydrogen gas accumulates on the electrode, especially the cathode during electrolysis, forming a barrier that impedes the flow of electrons. So let's move on to the next question. Question number 2 that says that the condition required for corrosion to take place, the condition that is required for corrosion to take place, just a minute, I just want to be sure that my audio is on. I don't know. I am not sure whether I turned, okay, I think I turned it on. Okay. All right, let's go back to Okay, let's go back to the question now. So, the condition required for corrosion to take place is the presence of A, oxygen and carbon 4 oxide, water and oxygen, carbon, water, and carbon 4 oxide, water and oxygen, water and carbon 4 oxide. So let me know what you feel the answer is in the comment section. Okay. But if you look at it critically, the condition that is required for corrosion to take place is actually option B, water and oxygen. Very, very important. And that's why we call it moisture. Water and oxygen. When there is water and oxygen available, corrosion will definitely take place. Okay. So corrosion, especially rusting of iron, requires both water and oxygen. This facilitates the electrochemical reactions that leads to the formation of rusts, which is the hydrated iron 3 oxide. Okay. All right, let's move on to the next question as we look at question number 3. The enzyme used in the hydrolysis of starch to dextrane and maltose is it zymase, is it sucrase, is it amylase, is it lactase? So please let me know what you think it is in the comment section, but the answer is actually amylase. That is what is used in the hydrolysis of starch to dextrane and maltose. And amylase basically breaks down starch into simpler sugar or sugars such as dextrane and maltose during digestion or industrial processing. Okay. All right. So this question says that, let's take this icon away from here. In the laboratory, preparation of chlorine from concentrated hydrochloric acid in the presence of potassium tetraoxomanganate 7, the product is dried by passing it through what? Is it concentrated tetraoxosulfate 6, anhydrous calcium chloride, calcium oxide, or sodium hydroxide? One of the things that you should be looking out for is that you're looking out for a substance that will dry the chlorine that is produced, and it will not react further with that chlorine or have any impact on the chlorine whatsoever. So the option or the right answer here should be A. Concentrated tetrasulfate 6 acid is a very good substance that we use in drying chlorine, when we prepare chlorine from in the laboratory. So concentrated is a strong dehydrating agent that is used for dry chlorine gas by removing moisture. So it takes moisture away. Okay, so this one says that the monomer of nylon is it hydroxybenzene, ethane acid, benzene 1,4-dicarboxylic acid, ethane 1,2-diol. Is it ethane 1,2-diol, or which one of which of them are the monomers of nylon? The answer is ethane dioic acid. Ethane dioic acid. And nylon 6,6 is made from the condensation reaction of hexandioic acid and hexamethylene diamine, forming a polyamide. Okay, so that is the monomer there for you. Okay, okay. The principle of column chromatography is based on the ability of the constituents to A, react with the solvents in the column, react with each other in the solvent column, dissolve each other in column, move at different speed in the column. So the right option to this one, please put your answer in the comment section, is actually D, and it is move at different speed in the column, and that's the basis for separation anyway. So chromatography separates components based on their different rates of movement through a medium due to differences in the affinity for the stationary and mobile phase. Okay, so that's that for that. So please let's take note of that. Very, very important. Okay. So all right. The next question says that ammonium chloride can be separated from its mixture with common salts by, don't forget that ammonium chloride has a peculiar characteristics, of behavior. And that is one thing that we have on, or we capitalize on whenever we find ammonium chloride in any mixture that want to separate it out from. So can you separate it out from a mixture with common salts using distillation, evaporation, decantation, sublimation? Okay. The right answer is actually the sublimation. And the reason is because ammonium chloride has the ability to sublime when it is heated, So it turns directly from a solid to a gas, unlike common salt, which remains solid. So this physical properties allows for their separation. So sublimation, you can also find that in camphor, the air freshener you put at home, they move directly from solid to the gaseous phase. Okay, all righty. So the next question says that the ability of carbon to form long chain is referred to as alkylation, acylation, carbonation, catenation. So which one? The right answer there is catenation, D. And it's basically the self-linking property. That's catenation. The self-linking property of carbon atoms through covalent bonds to form long chains and complex structures. Okay. So the industrial preparation of hydrogen gas from water gas is referred to as, is it the Birch process, the contact process, the Haber process, or the Bayer process? So tell me. The answer is the Birch process. And the Birch process involves reacting water gas, a mixture of carbon monoxide and hydrogen with steam to increase hydrogen yield through the water gas shift reaction. Okay. So the next question says that the relative atomic mass of a naturally occurring lithium consisting of lithium 7,3, mass number 7, atomic number 3, 90% abundance, and then 10% abundance with that mass number of 6 and atomic number of 3. Is it 6.2, 6.8, 7.1, or 6.9? The answer is 6.9. And basically what you do is just a multiplication between your 90 multiplied by 7 divided by 100 plus 10 multiplied by 6 divided by 100. So when you do that, you have 6.94, or approximately 6.9. Okay, the color of litmus in an alkaline medium is it red, is it yellow, is it pink, or blue? Litmus in an alkaline medium is color blue. So litmus paper is blue color in an alkaline medium, and it is red in an acidic medium. So litmus turn blue in alkaline solution and red in acidic solution. This is a standard acid-base indicator of behavior. Okay, the compounds CH3, CH2, CHO, and CH3, CO, CH3 can be distinguished from each other using. So what you're distinguishing basically is an aldehyde and a ketone, So can we distinguish them using dilute ammonia, Benedict solution, Toluene's reagent, or sodium hydroxide solution? We can actually distinguish them using the option C, Toluene's reagent. So, like I said, CH3CH2, CHO is an aldehyde, and CH3CO, CH3 is a ketone. So toluene reagent oxidizes aldehydes to carboxylic acid and forms a silver mirror, but it does not react with ketones. Okay. Which of the following statement is true about 2-methylpropane and butane? 2-methylpropane and butane. They have different number of carbon atom. They are members of the same homologous series. They have the same boiling point. They have different chemical properties. So the answer is B. They are members of the same homologous series. They're both alkanes. Okay. So both alkanes and structural isomers, yes, hence belong to the same homologous series. Oh, yeah, exactly. So the process that requires the use of hard water in its operation is A, tanning, B, bottling, C, laundry, D, dyeing. We use hard water majorly in tanning. It's in tanning, that's A. And the reason is because hard water is rich in calcium and magnesium ion, which is traditionally used in tanning processes, aiding in the cross-linking of collagen in hides. Okay. The next one says that what is the concentration of a solution containing 2 grams of sodium hydroxide in 100 cm cube solution? Um, we are given the relative atomic masses to be that 2316 and then 1 for hydrogen. The answer here is 0.50, and this is how we arrived at the answer. So from the molecular mass, which is 40 gram per mole, we can calculate the mole of sodium hydroxide, which is mass over molar mass, and that is 0.05 mole. Then the volume used is about 100 cm cube, which is equivalent to 0.1 dm cube. So concentration is the mole divided by the volume. So we bring the mole 0.05 divided by the volume, and we end up having 0.5 mole per dm cube. Okay. The next one says that the radioisotope used in industrial radiography for the rapid checking of faults in welds and casting is A, phosphorus 32, B, cobalt 60, C, carbon 14, D, iodine 131. The answer to this one is actually cobalt 60. Cobalt 60. And cobalt 60 emits gamma rays and is used to inspect metal casting and wet for structural defects. Okay. The next one says that the compound produced when sodium peroxide is heated with excess sodium is it Na2CO3, Na2O, NaNO2, or sodium hydroxide? The answer here is what? Na2O. That's B. That's B. And you can see the equation there. That's just how it is. So this is what you get. All right. See. The next one says that the pollutant that contributes to the depletion of the ozone layer is CFCs, NO2, SO2, or CO2. The one that contributes is actually option A, which we call the chlorofluorocarbons, CFCs, chlorofluorocarbon. They are very, very dangerous. It affects the ozone layer, which in the long run affects humans too, because the ultraviolet radiation that gets to us becomes so much intense that can be, very, very damaging and can result in disease, cancer and so many other things that it can result in. Okay. So CFCs, we must be mindful of it. We must try as much as possible to do away with using materials that can introduce CFCs into the atmosphere to affect the ozone layer. So CFC release chlorine radicals in the stratosphere that catalyzes the destruction of ozone molecules. Okay. So which of the following properties is not peculiar to matter? Which of the following properties is not peculiar to matter? A, kinetic energy of particle increases from solid to gas. B, random motion of particles increases from gas to solid. Orderliness of particles increases from gas to liquid. Random motion of particles increases from liquid to gas. So let's look at the options carefully and then tell me which one you feel is the right answer to these question in the comment section. Okay. Now, if you look at it critically, the right answer is B. Random motion of particles increases from gas to solid. Okay. And this is not peculiar to matter. Just like the question says, which of the following properties is not peculiar to matter? So this particular B is random motion of particles increases from gas to solid. That is not possible because when you look at randomization, or random motion, it should be the reverse. It will increase from solid to gas, not from gas to solid. So random motion of particle decreases from gas to liquid to solid. So that makes that the right option because it is not applicable to matter. Okay, so cast iron is used in making what now? What do we use cast iron in making? Chains and agricultural implements, iron sheet and retort stand, nails and iron rods, stoves and cooker. So what do we use it in making? Let me know in the comments section, please. Okay. Looking at it critically, you can see that the right option here is option A, chains and agricultural implements. And the reason is because cast iron is hard and brittle and is often used for making heavy-duty items such as machine parts, chains, and plowshares. Okay. All right, now, so which of the following compounds is used as a gaseous fuel? Which of the following compounds is used as a gaseous fuel? Is it option A, option B, option C, or option D? So carefully consider it and let me know what you think the right answer is in the comment section. Okay, so the right answer is propine, CH3, C double bond or triple bond CH. Okay, and the reason is because propine is an alkyne and a gaseous hydrocarbon commonly used in welding torches as a fuel due to its high inflammability and energy content. Okay. So the next one says that the products performed when primary alkanols are oxidized using acidified potassium tetraoxomanganate 7 are what? So what are the products that are formed when the primary alcohol is oxidized using KNO4? Is it option A? Is it option B? Is it option C? Is it option D? So let me know what you feel is the right answer in the comment section. All right. See? And the answer is D, CH3, COOH, and CO2. That's an acid that is a carboxylic acid, and then to be precise, it can be an ethanoic acid or any acid that is equivalent or synonymous to the alkanols that was oxidized. And then CO2 will also be given off. So primary alkanols are first oxidized to aldehyde and further to carboxylic acid with prolonged oxidation. Carbon dioxide and water may form. In a controlled oxidation, CH3, COOH, ethanoic acid is expected. Okay. All right. See, so let's look at question number 23 now. And for this one says that alkanols have the general molecular formula. What is their general molecular formula? CnH2n minus 2, CnH2n plus 1 CHO, CnH2n minus 2 OH, CnH2n plus 1 OH. So the general formula is basically actually option T, CnH2n plus 1 OH. It's just from alkane. Just you knock off one hydrogen from alkane, you replace it with the hydroxyl functional group, and then so you still maintain the general formula of alkane. The only thing that you're just introducing now is that you're reducing, instead of +2 in alkane, it becomes +1 in alkanols. Then you introduce an hydroxyl, functional group, which is the OH. So alkanols are derivatives of alkanes where one hydrogen atom is replaced with hydroxyl hydrogen, given the general formula. Okay, question number 24 now. Which of the following is not an alkali? Is it CaOH2, NH3, NaOH, or AlOH3? Don't forget that alkalis are soluble what? They are soluble base. Don't forget that. So look at the options that we have there and look at which one do you think is not an alkali based on these options that we have been given up there. And the answer is AlOH3. It is not a soluble base, So it is AlOH3. Aluminum hydroxide is amphoteric. It can act as both acid and base, but it is not a strong alkali like sodium hydroxide or even like ammonia. So which of the following statement is correct about the periodic table? Is it elements of the same group have the same number of electrons shell? The non-metallic properties of the element tends to decrease across each period. Elements in the same period have the same number of valence electrons. The valence electron of the elements increase progressively across the period. The answer is actually D. The valence electron of the element increases progressively across the period, and that's very, very correct. So as you move from left to right across a period, the number of valence electron increases by 1 in each successive element. Okay. The metal whose ore can be concentrated by passing it through a magnetic separator. Is it zinc? Is it tin? Is it copper or calcium? The answer to this one should be zinc. That's option A. That's correct. So zinc ore, like zinc blades, zinc sulfide are not magnetic, but some ores, like magnetite in iron, can be concentrated using a magnetic separator. However, if the question concerns separating zinc from other impurities with magnetic prior, then magnetic separation can sometimes be employed. So, okay, let's move along now to question number 27. An example of an acidic oxide. Don't forget that we talked about oxide, that it can be either acidic, basic, or neutral. And we also have amphoteric oxides too. So don't forget those things, like we have touched on them in the course of the teaching. So this question is asking that an example of an acidic oxide, is it option A, option B, option C, or option D? And the right answer is option C, SO2. Now, why did we choose SO2? Sulfur dioxide is a typical acidic oxide. It reacts with water to form sulfurous acid. So SO2 is an acidic oxide. That's very, very correct. Okay. Another acidic oxide is NO2. Another acidic oxide is CO2, So these are some other acidic oxides that we have. Okay. Moving along now and looking at the 28th question, which is what volume of 0.5 molar H2SO4 will exactly neutralize 20 cm cube of 0.1 molar sodium hydroxide solution? The options that you have there are listed there. So let me know, work it out, just work it out, and let's have the answer in the comment section. Make sure you are engaging this question. Don't just look at them and expect the answer from me and then, oh, you will explain, I will give us the answer. No, try it. Even if you miss it, you know where you've made a mistake and you'll be able to correct yourself subsequently. Or if peradventure you see such a question coming to you. Okay, so looking at this question critically, you discover that the right answer here should be option A, 2.0 cm cube. And the reason is this. When you combine H2SO4 plus sodium hydroxide, you need 1 mole of H2SO4 that will react with 2 moles of sodium hydroxide to give us Na2SO4 plus 2 molecules of water. Now, using the titration formula, C1 V1 over N1 equals to C2 V2 over N2. Now, when you now do that, don't forget that what we are looking for is V1. We know our C1 to be 0.5 as stated. We know our N1, the number of moles of the acid, is 1. We also know that our C2, which is the molarity of the base, which is 0.1, and then the volume of the base that was used was given to us as 20 cm cube. And then the number of moles of the base is actually 2. So when you do that and you make V1 the subject of the formula, you end up having the answer as 2.0 cm cube. Thank you. Okay. Moving along now, diamond cannot be used, A, in making bicycle chain, as abrasive, in cutting glass and metals, as ties for drawing wires. So what is the right answer there? It cannot be used as it cannot be used in making bicycle chain, which is option A. We don't use this in making bicycle chain. So diamond is hard at Vitron, suitable for load bearing or flexible component like chains. It is ideal for cutting tools and abrasives. Okay. All right, now moving on to the 30th question, which is ethanol is soluble in water due to the presence of carbonyl group, hydroxyl group, phenyl group, methyl group. Why is ethanol soluble in water? The reason is not far-fetched. The reason is because of this particular functionality of ethanol. That is its ability. Because it has the hydroxyl functional group. So the answer there is B, because of the hydroxyl group. So that's why it is soluble in water. because the hydroxyl group forms hydrogen bond with water, making ethanol slightly miscible. So it makes it slightly miscible. So let's take note. So move on to the next one. Question 34 says that the number of electronic shells contained in an atom with electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 is A3, B2, C4, D5. So, what do you think the answer is to that? Let me know in the comment section. All right, see? The answer is actually C, which is 4. That's for electronic shell. How did we arrive at that? Very, very simple. All we just did was like um to look at the number of so look at each number before the orbital letters. Then we have 1s, 2s, etc. So this one represents a principal energy. That is a shell in this configuration. We see electrons in 1s shell. You have 1s, and sorry, the first shell, which is 1s, the second shell, 2s and 2p, the third shell, 3s and 3p, and then the fourth shell, that's the fourth energy level, the fourth principal energy level is which is 4s, and that is where you have the electrons distributed. So there are a total number of 4 shells in that particular electronic configuration. Okay. Oh. So we move on now to the 32nd question, which says that the drying agent suitable for ammonia is a calcium chloride, calcium oxide, phosphorus 5 oxide, concentrated H2SO4. We must be mindful of something in our choice of drying agent for ammonia. We must look for a drying agent that will not react with ammonia or that will not interact with ammonia, therefore defeating the purpose of wanting to use it to dry it. So you must carefully select between option A and option D. And if you look at this carefully, the most suitable of them is actually option B, calcium oxide. And the reason is, like I said, okay, to choose a suitable drain agent, just like what I just said now, you must look for one that will remove moisture and does not react with ammonia. So the most suitable is calcium oxide. And the reason is because, it absorbs, moisture efficiently, and it does not react with ammonia, and it is suitable for drying, ammonia. Okay. All right. So the next one says that the arrangement of particles in crystal lattice can be studied using the arrangement of particles in crystal lattice can be studied using X-rays, beta rays, alpha rays, gamma ray. So which one do you think is the right answer? Okay, the right option is actually option A, which is X-rays. So we can look at that. X-rays have wavelengths similar to the distance between atoms in a crystal. When X-rays are directed at a crystal, they are diffracted by the atom in the lattice. The resulting diffraction pattern can be analyzed to determine the atomic structure of the crystal. Okay. In the extraction of iron, the waste gas from the furnace is a mixture of, is it A, B, C, or D? Okay. The answer to this one is option C, N2, CO, and CO2. And the reason for that option, for picking that option, is because when you look at the reaction in the blast furnace, you have something like this happening there. Carbon reacting with oxygen, carbon dioxide being formed reacts with more coke or carbon, and then gives us carbon 2 oxide, and then that reacts, with iron oxide, and then it gives us iron, which is the desired, and then CO2 is then formed. So the waste gas commonly released include carbon monoxide, carbon dioxide, nitrogen from the air blast, and so on and so forth like that. So let's take note of that. Very, very important. Okay. So we move on to the next one now. We'll look at the next question very, very fast. Okay. It said in a neutralization reaction involving HCl and sodium hydroxide using litmus as an indicator, the color at the end point is, that is the color when there's a complete neutralization is blue. Is it blue? Is it red? Is it orange or purple? Don't forget that the color of litmus paper in acid is red, and that for litmus paper in alkaline or basic solution is blue. So when you now have a neutralization reaction, that means you should like a mixture of both, so to speak, acid color and the basic color. Yeah, you can actually interpret it that way. And that will give us the color when the endpoint is reached. So the answer is actually purple, yes. Purple. And basically litmus indicator behavior in acid is red. In basic solution, it is blue. At neutral pH, which is around 7, purple. That is the intermediate between red and blue. So that's that for that. Okay. So therefore, at the end point of the neutralization reaction between HCl and sodium hydroxide, the solution becomes neutral and litmus turns purple. An example of a solid emulsion is it A, butter, B, air cream, C, milk, or D, cod liver oil? The answer is butter, and the reason is because solid emulsion is where the dispersed phase is a liquid and the dispersion medium is a solid. So butter is a solid emulsion. Water droplets dispersed in solid fat. So dispersion medium is a solid fat, and then the dispersed phase is liquid or water, as the case may be. Okay. An isotope has an atomic number of 15 and a mass number of 31. The number of protons it contains is, the number of protons it contains is A, 16, B, 15, C, 31, D, 46. So what is the number of protons? Don't forget that the proton number is synonymous to the atomic number. So based on this statement that I just made now, I've actually given you an insight into what the answer is supposed to be. So carefully looking at it, if you are told that the atomic number is 15, then automatically the proton number is also what? Is also 15, from that statement. So just like what I just said, and that's the explanation why that is so. Okay, so the proton number is also 15. All right, see? So this one says that you should calculate the volume in cm cube of oxygen evolved at STP when a current of 5 amperes is passed through acidic water for 193 seconds. So we have the constants, fire has 96,500. Then the molar volume of gas at STP is 22.4 dm3. So when you look at that, the options that you have are listed there. When you work it out very well, the answer you have should be A. And this is how we got that particular, answer. Okay. So it's just a stepwise, calculation, just like what you see. The charge is calculated from Q equals to high T. Then electrolysis of water, you show the reaction and you see that it's 4 electrons, 4 moles of electrons, produced from 1 mole of oxygen. So you can use that to extrapolate, and then you know the moles of oxygen that will be produced from there. And when you do it right, what you have as the volume is 0.056 dm3. Okay. Okay. The gas that is used for the treatment of cancer is A, neon, B, radon, C, xenon, and D, argon. So the answer to this one is radon B. And the reason is because radon is a radioactive noble gas. It emits alpha, particles, which can be used in radiotherapy to destroy cancerous cells. Although its use has declined due to safety concerns and better alternatives, radon was historically used in the treatment of certain types of cancer. Okay. So the next question says that a chemical reaction in which the hydration energy is greater than the lattice energy is referred to as A, reversible reaction, B, a spontaneous reaction, C, an endothermic reaction, D, an exothermic reaction. And the option there is exothermic reaction. The reason is because if hydration energy is greater than lattice energy, then more energy is released by hydration that is required to break the ionic lattice. The overall energy change is negative, meaning meaning the process releases energy. It means that the process releases energy, okay? Then this next one says that given that equation above, what is y? So this is more like a redox reaction whereby you separate into two half cell equation. That is the reduction half cell and then the oxidation half cell. And then from there, you'll be able to calculate what that will look at. So the answer is actually C. And how did we go about that? Looking at it stepwisely, like I said, divide into two half cells, reduction half and the oxidation half, then try to balance the electrons electronically and atomically as the case may be, following the steps that we outlined, when we were looking at redox. So please, let's follow that and then we'll be fine. So the steps to follow and how to go about it is what is listed on the screen there. Okay. The next question says that we should look at this particular compound, and the compound above exhibits what? Is it geometric isomerism, positional isomerism, structural isomerism, or optical isomerism? So let's look at it very well. What we have there, that is actually an optical isomerism. Why is that? The reason why we say it is optical isomerism is because the compound given, or the given compound is lactic acid, which contains a chiral center. A chiral center means that a central carbon that has 4 different functional groups attached to it, So it is bonded to different, 4 different functional groups. We have the methyl group, we have the hydroxyl group, we have the carboxylic acid group, and then we have the hydrogen atom group, okay? Okay, so based on that, if you look at it, because this carbon has 4 different substituents, it is a chiral center, making the compound optically active. It can exist in 2 non-superimposable mirror image forms, that is enantiomers, which is the hallmark of optical isomerism. So this is why it will exhibit optical isomerism. Okay, so please don't let us forget that. Very, very important. Now, looking at this monosaccharide, please pardon the P and the Q. It's supposed to be directly on top of the reversible arrows, so one above, the P above, the Q directly below. So to give us polysaccharides and then water like that. Now, in the process above, P and Q respectively represent A, condensation and hydrolysis, B, fermentation and condensation, C, polymerization and hydrolysis, and then D, polymerization and condensation. So basically, we know that when we are having a monosaccharide, which is like a monomer, giving us a polysaccharide, that is polymerization. That is established, right? Very, very good. So the next thing that we need to look at is that, okay, look at the water and all that is now also coming off as a result of this particular reaction. And then to be able to now decide that, oh, is this a condensation reaction or an hydrolysis, as the case may be? So we carefully ponder on that before we choose our option. And if you look at it closely, the option is polymerization and hydrolysis. Now, the reason is because the P, the fourth reaction is a polymerization reaction where monosaccharides, e.g., maybe glucose, join together to form polysaccharides like starch or cellulose and so on and so forth, releasing water, a condensation polymerization. Now, Q is the reverse reaction. This is actually hydrolysis, where water is used to break down the polysaccharide back into the monosaccharide unit. So it involves you carefully considering, the forward and the backward reaction for you to be able to know what is happening there. Oh, you don't just say that, oh, I think it is polymerization and condensation. No, it is a condensation polymerization, which is the forward reaction, but reversing it. It is what? Hydrolysis. Very, very important. So please, let's take note of that, and so that we don't get confused. On to the next one. Question 44 says that the functional group present in the compound above are, when you look at it carefully, is it option A, option B, option C, or option D? If you look at it, you may get a bit confused, and the confusion may be, oh, should I choose between an hydroxyl and allo group or an hydroxyl and chloro group? They look similar, actually, if you look at it. Yes, they look very, very similar. But based on the context of this question, one is more suitable than the other one. One is more suitable than the other one. And the most suitable one is option D, which is the hydroxyl and halo group. Hydroxyl and halo group. Now, the reason is because option B is also essentially, like I said, pardon me, please. Like I said, both of them is correct, but one is more suitable than the other. Now, option B is also essentially correct, but option D uses the proper terminology, halo group, which is more general and matches the wording of the question. So that's just the difference. They both looks correct or they are both correct, but based on the question, in the wording of the question, the most suitable terminology to use is what the halo group instead of the chloro group. Halo group it connotes that, oh, halogen, which is not just chlorine alone, so it's a more expansive, not restricted. So question 45 says that in the diagram above, S is the A enthalpy, B activated complex, C activation energy, and D enthalpy change. Enthalpy change. So let's look at it. It's between the reactants and the products. So the answer is enthalpy change, which is option D. And the reason is because S represents the energy difference between the reactants and products, which is the enthalpy change, delta H of the reaction. Okay. We are looking at another graph or so to speak, or another diagram now. So the diagram represents, is it a spontaneous reaction, an exothermic reaction, a non-spontaneous reaction, or an endothermic reaction? So let's look at it together. The product is formed below the reactant. These are some of the things that we must be looking out for. And if that is the case, what do you think that kind of reaction would be like? That's one hint. It's an exothermic reaction. The reason is because the product, like I said, is formed below the reactants. Reactants start at a higher energy level than the product. This indicates that the energy is released as the reaction progresses. Therefore, the overall enthalpy change is negative. This is characteristic of an exothermic reaction. Okay, now let's look at this one. The curve depicts titration between a strong acid of pH, strong acid and strong acid and weak base, C, weak acid and weak base, D, weak acid and strong base. The answer to this is strong acid and strong base. And the reason is because the pH curve in the diagram shows the following characteristics. Initial pH is very low, pH 1 to 2, indicating a strong acid. This is a sharp rise, or there is a sharp rise in pH near the equivalence point. The equivalent point occurs around pH 7, which is neutral. So that's that. So a strong acid and a strong base titration result in a sharp vertical rise and an equivalence point at pH 7. Okay. From the diagram above, an ideal gas can be represented by, is it K, is it M, is it L, or N? Now, looking at it, option N is the most suitable. And why is it the most suitable? From the ideal gas law, PV equals to nRT. Now, at constant temperature and amount of gas N, the product PV remains constant regardless of pressure. Now, this means that the graph of PV versus P for an ideal gas should be a horizontal line. That is, PV is constant. From the diagram, curve N is a horizontal line indicating PV is constant with changing pressure. This matches the behavior of an ideal gas. Matches the behavior of an ideal gas. Okay. So let's look at this one. It says CH4 plus Cl2 to give us CH2Cl plus HCl. The major factor that influences the rate of reaction above, is it concentration? Is it catalyst? Is it temperature or light? The major factor will be light, which is option D. The reason is because this is a chlorination reaction, specifically a substitution reaction of methane with chlorine. This type of reaction is known to produce through a free radical mechanism. So free radical halogenation of alkanes like methane requires ultraviolet light or sunlight to initiate the reaction by breaking the Cl-Cl bond, which we refer to as the homolytic fission. And then that sets off the reaction. It's like an initiation. It sets off the reaction and it keeps on going like that until it is terminated when there are no more chlorine to work with or hydrocarbons to react with. Okay. And the last question for this particular Jamb question says that in the reaction above, an increase in temperature will A, increase the reactant production, B, increase the value of the equilibrium constant, C, shift the equilibrium to the left, D, decrease the value of the equilibrium constant. The answer to this is increase the value of the equilibrium constant. And the reason is because for an endothermic reaction, increasing temperature shifts the equilibrium to the right, increasing the concentration of the product, which increases the equilibrium constant. All right, thank you for joining me in going through this Jamb pass question. I'll see you again when we solve the next Jamb pass question. Take care of yourself. See you next time.